Welcome to clickmyproject.com. Let's discuss on the title, a universal denoising framework with a new impulse detector and non-local means. Image denoising is one of the most fundamental, widely studied and largely unsolved problem in digital image processing. Its objective is to recover the original image or the best estimation from noisy data while preserving image details. Unlike previous denoising methods which were developed under local regularity assumption, the NL-means exploits the correlation in the entire image. Basically, the NL-means filter estimates a noise-free intensity as a weighted average of all the pixel intensity in the image, and the weights are proportional to the similarity between local neighborhood of the pixel being proposed and the local neighborhood of the surrounding pixels. Therefore, these non-local methods are very powerful in preserving image details when denoising. We propose a new detector based upon new statistics called as robust outlying ratio, called as ROR, which is used to measure how much a pixel looks like an impulse noise. Based upon the ROR, the pixels are divided into 4 different clusters. Then, different decision rules are adopted to detect the impulse noise in each cluster. During the detection process, the form close to find strategy is used. In addition, detection processes contain 2 stages. The core stage followed by the find stage. Different thresholds are used to 2 stages. Finally, the detection procedure is iteratively adopted. Further, as aforementioned, the NL means is very powerful for denoising Gaussian noise. But to the best of our knowledge, it is not yet extended to remove impulse noise. In this paper, NL means is extended to clean impulse noise, and then a universal noise removal framework is proposed by combining NL means with the new detection mechanism. Let's have a look on the data flow diagram. This is the data flow diagram about universal denoising framework. First, you have to select an input image and add impulse noise on it. The same image you have to add Gaussian noise, and you have to estimate the noise level using 2 parameters, namely MSE and PSNR. And with the help of the noise estimated parameter, you have to go to ROR calculation. In this ROR calculation, 4 clusters will be formed. Depending upon the cluster value, core stage filtration, which is followed by fine stage filtration, will be done. And then you have to implement the NLM implementation for removing the impulse noise, and again the impulse noise removed image will be subjected to secondary NLM to remove the Gaussian noise. Now let's look on to the execution of the program. Right click main denoise.m file and press run file. This is the guide designed for the execution of our program. Select input image. You can select any one of the images, and then you have to add noise level. You can select any one of the noise level as salt and pepper noise, and to the same image you have to give Gaussian noise, and you have to estimate the noise parameter. This is MSE called as mean square error, PSNR called peak signal to noise ratio. And now you have to perform ROR calculation. In this ROR calculation, the pixel position, that is the index position, will be returned in the cluster tables, and it will be divided into 4 clusters. And this is the fine stage filtered image. Before that, the core stage filtration will be done and the fine stage filtered image is displayed. These are the cluster values. For cluster 1, which are the pixels entered there, for cluster 2, 3 and like 4. This fine stage filter image has removed some of the salt and pepper noise, but the Gaussian noise has been still there. Now you can go on to the NLM filter to remove the impulse noise completely. This may take some time. This is the output of NLM filter, which has removed the impulse noise completely, and this is the PSNR value achieved for that, 24.7882. Now you can implement the secondary NLM to denoise the Gaussian noise, and you have to bring out the increase in the PSNR performance, that is from 24 to a larger number. This may also take some time. This is the final output, which is a denoised Gaussian noise, and this is from NLM secondary filter, and this is the PSNR value achieved, called as 36.1272, a better denoising ratio. And the proposed approach can be adapted to various models such as salt and pepper impulse noise, random valued impulse noise, and the mixed noise by modifying some parameters in the algorithm. Extensive simulation revealed the performance of the proposed algorithm is good. Thank you.